Namaste and welcome everyone. I hope everyone is doing fine. Do you know for a life to evolve in any planet requires a basic organic matter? And where does this matter comes from? Recently, organic matter has been found in a comet. The organic molecules found in abundance on Comet 67P, also known as Churyumov-Gerasimenko, are essential for the emergence of life on carbon-based systems. The discoveries may have implications for how life first began on Earth because comets are thought to be the source of complex molecules necessary for carbon-based life. The group, which included researchers from the University of Bern in Switzerland, used information gathered between 2014 and 2016 by the Rosetta spacecraft and processed by its mass spectrometer. Rosina. Comet 67P, also known as Churyumov to scientists, was visited by Rosetta and its Philae lander in 2014. 2 years later, Rosetta ended its mission by purposefully crashing into the comet. These data allowed the researchers to for the first time identify a number of complex organic molecules on a comet, revealing what they refer to as the comet's organics budget. The kinds of molecules that comets might have carried are also covered in more detail in the research. According to a statement from Nora Hani, a postdoctoral researcher at the University of Bern's Department of Space Research and Planetary Sciences. It turned out that, on average, Chury's complex organics budget is identical to the soluble part of meteoritic organic matter. As important suppliers of organic material, impacting comets are therefore likely to have contributed to the emergence of carbon-based life on Earth. According to Hani, a mass spectrometer on NASA's Cassini spacecraft discovered that the organic material falling on Saturn from its innermost ring is similar to the molecular budget of Chury. Thanks to a phenomenon that happens when comets pass close to the Sun when ices within them start to melt and erupt from their surface. Rosetta was able to conduct a more thorough analysis of the chemical composition of Chury and its larger molecules. The comet Chury became active as it drew nearer to our star in its orbit. Ice that was sealed inside the comet immediately changed from being solids to gases, a process known as sublimation, and were then released from the surface in an outflow. This gas jet carried particles of surface-level dust with it. The sun's radiation then heated these particles to much higher temperatures than what they would have reached on the comet's surface. As a result, larger molecules are desorbed or released from the dust, making them accessible for Rosina's detection and analysis. What smell does Comet Chury emit? Chemicals made up of numerous atoms, such as complex organic molecules and molecules never before found in a comet, were previously concealed in the comet's dust but were now exposed by Rosina's analysis. These included traces of some earthly substances that contribute to the creation of well-known fragrances. Hani said, "We found, for example, naphthalene, which is in charge of the distinctive smell of mothballs." Hani adds, "And we also discovered benzoic acid, a naturally occurring component of incense." These heavy organics would apparently make Chury's scent even more complex, but also more alluring. We also found benzaldehyde, which is frequently used to give foods an almond flavor. The synthesis of biomolecules like amino acids and sugars is aided by some of the other molecules, such as formamide, which have what is known as prebiotic functionality. The team considered Chury's organic budget in the context of the entire solar system, including the gas and dust clouds that burst into new stars and planetary systems. This provided more evidence for what scientists have long hypothesized about comets like Chury, that they may serve as fossil records of the components used to create the solar system's planets 4.5 billion years ago. According to Suzanne Wampfler, an astronomer at the University of Bern Center for Space and Habitability, we not only find similarities of the organic reservoirs in the solar system, but many of Chury's organic molecules are also present in molecular clouds, the birthplaces of new stars. Our results confirm that comets do indeed carry material from the times long before our solar system emerged and are consistent with and support the scenario of a shared pre-solar origin of the different reservoirs of solar system organics. Do you know that Earth can leave our solar system? To watch that topic covered in a video, click above. If you have liked our video, or if you think we are able to provide some relevant information about space exploration, do subscribe now and like the video. Please hit the subscribe button for astronomy, cosmology and science updates. Thank you and have a great day.